Alright, as we look at this from class on Friday, there's two ways to have a horizontal asymptote. One way is if the denominator's degree is greater than the numerator's degree. And in this case, it results in a horizontal asymptote y equal to 0, no matter what the difference is. So if I have f of x equals x over x to the 100 minus 2, no difference. You're still going to have a horizontal asymptote of y equal to 0. Once again, what is this? What is the horizontal asymptote? The horizontal asymptote is what the graph is going towards, the y value as x goes to positive or negative infinity. It's the ends of the graph, and again, horizontal asymptotes are describing end behavior. If you look at the second f of x here, when the degree of the top is the same as the degree of the bottom, then all we're going to do is, because the overall, as it goes to, again, as x goes to positive or negative infinity, the top and bottom sort of cancel each other out. I mean, it's staying relatively the same. So we just take the proportion of the numerator leading coefficient to the denominator leading coefficient. So in this case, it would have a horizontal asymptote y equal to 1/3. Again, think about the growth rate of the top and bottom. That is your reasoning for this. I don't advise trying to just memorize rules. It's important, especially as you go through pre-calc and calculus, that you know what we're talking about as the degree of the bottom grows faster than the degree of the top, or vice versa. Looking at one more example here. So if I have g of x equals 2 minus 3x squared over 5x squared plus 4x minus 1. As I look at this, again, the degree of the top is x squared. The degree of the bottom is x squared, or I'm sorry, the degree is 2. Even though the top isn't in standard form, that doesn't negate the fact that the degree is 2. I would just look at the leading coefficients, and again, because the functions stay relatively steady towards each other, we go -3/5 as my horizontal asymptote. I would strongly encourage you to graph all of these functions and again visualize what's going on, exactly how is a horizontal asymptote occurring as the graph goes towards it. When the degree of the top, so if the numerator is greater than the denominator, and again it's talking about degree, then that means we're going to have a slant asymptote or oblique. This is because if you flip what happened for the numerator and denominator in the first example, now the top is growing much faster than the bottom, meaning it's going to go off to infinity or negative infinity, depending on the x value that you plug in. So being that this is growing much faster, it's going to go to infinity, and it does follow a pattern which will be like a slant. So depending on the difference between the degrees, again, this will result in a slant asymptote, and here's why. Anytime you have a degree of the top greater than the bottom, you have to divide. In this case, it is x minus 1. That's a linear divisor. So I'm going to use 1 as my 0, and then use the coefficients of the top. Use synthetic division, so I drop down this 1. 1 times 1 is 1. 4. 4 times 1 is 4. And I get a remainder of 3. In this case, the result here is going to be my slant asymptote. So I would have a slant asymptote at y equals 1x plus 4. I encourage you to graph g of x. And when you graph g of x, you should see that it would follow an imaginary slant asymptote at x plus 4. So something along these lines here. If I go over to f of x, same thing results. I have a degree of 3 on top and a degree of 2 on the bottom. So this is going to go to a positive or negative infinity. So it's not going to follow a horizontal asymptote. It would be the same thing as the right. It would be a slant asymptote. And what we have to do is divide the top by the bottom. And in this case, I showed a second example because in this case we don't have a linear divisor, so we have to do the dreaded polynomial long division. So we have x squared plus 0x. On this side we have x cubed plus 0x squared plus 2x minus 1. So when I multiply x squared to get x cubed, I multiply it by x. X times x squared is x cubed. X times 0x is a 0x squared. x times 1 is a plus 1x. In typical long division, you subtract down. So for polynomials, I like to, this is the only time I do a double change. So that'll cancel when I add down. This was already 0, so that's gone. And 2x minus 1x is just x. And then I drop down the next term. As you see, I'm not going to be able to get x squared down to here. So this, folks, just like the last example, we ignore the remainder, and it's a positive x. I'm sorry, that little dot might look like it was a negative. So what do I have? I have a slant asymptote, or oblique, at y equal to x. So again, if you graph this in your calculator, which I strongly suggest you do because we're going to be graphing these on our own soon by hand, you would see that it would follow an imaginary line right down the origin. And again, my imaginary line there is not drawn to scale. Let's look at one last example. Last example of an asymptote, and I could go on and on with these, but I want to show you one last thing. When the degree of the numerator is greater than the denominator, what can result? Now the last two were slant asymptotes because when we divided the top by the bottom, we ended up getting a linear function as a result for the quotient. Now if you notice, the degree of the top here is 3, and the degree of the bottom here is 1. There's a difference of 2. So a quadratic asymptote is going to result. I purposely made this one so I could use synthetic. So I go 2 and then 1. Don't forget the 0 for x squared. It seems to be an issue for some. Please don't forget that. Drop down the 1. 1 times 2 is 2. Add down. 2 times 2 is 4. Add down is 6. 2 times 6 is 12. Add down. We get 9. So if I were to graph this, I would have a quadratic asymptote at x squared plus 2x plus 6. And again, I strongly encourage you to graph the original function h of x in your calculators, and from there you will be able to see that it tends towards a parabolic asymptote. In class, again, we're going to be putting this all together. If you have any questions, please post to the Edmodo class page. I'll be talking about this more tomorrow in class. Have a great Sunday. And if you made it to the end of the video, I give you a shout out. You're now part of the Mathletes United Mathletes team. Mad Math. I'm not sure what period 3 calls it, but there you go.